This chapter will help you with your final project in the course because it has a simplified chart showing how to identify the general types of clouds. But we'll start by talking about atmospheric moisture more generally. You already know that water and any substance can exist in multiple states of matter that are determined by the combination of pressure and temperature. The terms for most of these transitions between states of matter are already familiar to you, but there are two that you may not know. Sublimation is the change from a solid to a gas without passing through the liquid state. The reverse, a gas to a solid, is called deposition. These two processes will only occur in cold, dry places. Calling air dry requires a little more explanation because it's dependent on both water content and temperature. Humidity is a term for the amount of water vapor in air, but more specifically, the term relative humidity is what is being used in most cases, especially when you see humidity within a weather report. Relative humidity is the proportion of water that can be held by air at any particular temperature. At any relative humidity below 100%, liquid water will evaporate until the air reaches saturation. At 100% relative humidity, water vapor will normally condense to form precipitation. Now, there are some situations where relative humidity can exceed 100%, but those require undisturbed air and air without dust. The previous image held temperature constant. Water would continue to evaporate until 100% relative humidity was reached. However, we know that temperatures change. As a result, relative humidity can change without a change in the amount of water vapor in air. As temperature decreases, the amount of water vapor that can be held also decreases, thereby raising the relative humidity. And this is why relative humidity changes during the day, even though the amount of water vapor held by air usually does not change quite as quickly as the temperature. Lower temperatures create higher relative humidity. Once air hits 100% relative humidity, water vapor condenses. For any given volume of water in the air, you can reduce temperature enough to hit 100% relative humidity. That temperature is called the dew point. Once dew point is reached, water vapor changes to a liquid. On the surface, water vapor forms dew because land changes temperature quickly. Clouds form a little differently. Water vapor still condenses to form a liquid, but the reason for the cooling is mainly due to a reduction in air pressure higher in the atmosphere. Air that is allowed to expand has atoms and molecules more spread out, meaning that they are less likely to vibrate against other atoms and molecules. With fewer collisions, there is less thermal energy, so temperatures decrease. So the key to forming clouds is to lift air so that it can expand and decrease in temperature. Orographic lifting occurs when the shape of the land surface forces air to higher elevations. In this image, the dominant wind is from the left to the right. The air approaches land from the ocean, where it was nice and warm and absorbed lots of moisture. Once the air mass starts to be forced up because of the mountains, it cools and rain falls on the windward side of the mountains. Once air reaches the other side of the mountain range, it lowers, warms, and soaks up any surface moisture, and this is the cause for many deserts. The reason for most clouds and rainfall for most of the United States is from frontal wedging. This is where air masses of different temperatures approach each other. The cooler mass will be denser, forcing up the warmer air mass, which then decreases in temperature and forms liquid water. Frontal wedging is common away from the oceans. In the oceans and around land surrounded by oceans, air masses of similar temperatures can converge, forcing all of the air up. Because there is a large amount of air forced up and the air is heavily laden with water because it's been over the oceans, this process is responsible for many tropical storms. The last way to lift air occurs by unequal heating of the land surface. The areas that warm more heat the air, which then rises. This convective lifting occurs naturally, but it is especially pronounced in cities and is part of what is known as the urban island effect. Roads and rooftops will absorb more solar energy than grass and trees. This is one of the reasons that it rains more in cities than in rural areas. At this point, we are looking at multiple factors regarding how air behaves. If we heat a mass of air, it becomes less dense and it rises. But as it rises, air expands and becomes less dense because it's cooling down. And that cooling then causes air masses to become denser again. So are you confused yet? Okay, obviously all of these factors and others are responsible for the cycling of air within the atmosphere. So let's think about two basic categories. Air that doesn't move vertically or generally returns to its same position is considered stable. Air that shows significant vertical movement is considered unstable. So there are three general types of stability. Absolute stability means that rising air masses are always cooler than the surrounding air. When you see clear skies, this is usually the reason. Clouds can occur during these conditions because of other factors. However, because air is unlikely to move up or down very much, any clouds that do form will be in thin layers. There's little vertical movement of air, so there's little vertical distribution of clouds. The exact opposite is absolute instability, and this occurs when rising air masses are always warmer than the surrounding air. Because the rising mass of air is warmer, it is less dense and therefore prone to rise even more. Generally, that warm rising air is taking moisture away from the surface, so this condition typically causes thick layers of clouds to develop. Conditional stability refers to the situation when the relative temperature difference between an air mass and its surroundings vary with altitude. Basically, air is stable when dry and unstable when saturated with water. Now, this vertical difference forms towering clouds and causes severe thunderstorms. This image from your book will help you put names on most clouds. The two things that you want to determine are the form and the height. Form refers to the shape of the clouds. Cirrus clouds are thin and wispy. Stratus refers to types of clouds that form broad layers where you cannot normally make out the individual clouds. The cumulus group consists of clouds that sort of look like individual cotton balls. And there are many other names for clouds out there, but most of them are really just combinations of these three major categories. The shape of clouds is partially related to the altitude at which they occur. Low elevation clouds are in the warmest air masses, meaning that they can hold the most moisture. And that also means that they produce more precipitation than the middle clouds. High clouds produce extremely little precipitation because air that high and that cold is not able to hold much water to begin with. At the far right on the image is a group of clouds that it's not easy to classify. They tend to occur at various elevations and in various forms. Some are associated with nice weather, some with hurricanes. The best generalization that can be made is that when clouds become vertically developed into a solid tower, you can expect a serious thunderstorm. Some books will consider fog a boundary between clouds and dew. Your book considers fog to be a type of cloud in which the bottom is at the Earth's surface. Now, while clouds form from cooling that results from rising air, fogs form a little differently. Cooling clouds form when warm, moist air moves over a cool surface. Either land can be cooling or the warm air might be blowing in. Evaporation fogs form when cold air receives moisture, either from an overlying moist warm air mass or from the below Earth's surface. Water vapor changing to liquid water to form rain, to form snowflakes, is a complex process. And even though your book suggests that these processes that form rain are now known, there are still a lot of questions. Certainly the processes seem to differ a little based on the temperature the air mass is generating the droplet. And there are other possibilities than just the two mentioned within your textbook. Ultimately, they're all sort of the same. Water molecules are packed together physically until their mass is too large to be held up in the atmosphere. So ultimately, gravity wins.